Hello and welcome. I'm Stephanie Fernstark, and this is the fourth video in a series on Metatron's cube numbers and the fruit of life and its matrices. I'm glad you are joining me. Our focus will be more in the matrices than it has been in previous videos. This information is joyfully being received and in turn returning to all of us now. I have come to know that the magic happens in allowing the fun play in this sacred space. I hope you are dancing with the universe. That's always my intent for myself. Recently, I have realized that I was mispronouncing the words chiral and chirality, so there's a change there. Let's see what the spiral is showing us next. The first video in this series was on the Metatron's cube numbers in the fruit of life. Today we are just looking at a broad general overview of that to see what will be reflected, as that's what I think is fun and magical. If you are interested in a more in-depth look at the numbers, I invite you to check out that first video. Here we will see a couple trilogies of numbers that will be seen today in the matrices, and that will be a 5, 2, 8, and another one being the 1s with the 4s and the 7s. We have in past videos spoken about the hidden 0, 9. That will be reflected with the duplicate 3s and 6s in the matrices. We will also see that it shows us the numbers summing to 9 in different ways. So we have the 1 across from an 8, a 2 across from a 7, and a 4 across from a 5 here. Also true of the chiral is the pairings that sum to 9. Both the matrices and Metatron's cube numbers in the fruit of life use the addition of adjacent numbers to populate the information that we receive. And an example of that for us is our 8 plus a 4 is 12 with the digital root of 3. Adding the 3 back into the 8 is 11, giving us a digital root of 2. We can use that math pattern to receive the other 5 numbers in the chiral and their position. Metatron's cube matrices is a grid of 9 columns and 18 rows. The cube is a 9 by 9 digital root matrices. The digital root, as we refer to the method today, was used as early as 950 AD, called casting out the nines and Hindu method. And that is, as we mentioned, taking larger numbers and reducing them to single digits. So 123 would equal 6, or have the digital root of 6, and an 11, as we've said, has the digital root of 2. Here we do use the adjacent numbers and add those together to populate all the rows. So we have our 1 plus a 2 equaling 3, our 2 plus a 3 equals 5, our 3 plus a 4 equals 7, 4 plus 5 equals 9, 5 plus 6 equals 11 digital root of 2, our 6 plus a 7 is 13 digital root of 4, our 7 plus an 8 is 15 digital root of 6, and our 8 plus a 9 is 17 digital root of 8, and then we wrap around to grab the first number with our last one. So our 9 plus a 1 is 10 digital root of 1. After we have completed the 18th row, it does repeat itself and become a duplicate matrices, which means we can create and expand this infinitely out with those duplicate matrices. Another fun thing to think is that we can create a numeric chorus out of this. We can wrap around the top row so that it meets the bottom row and matches up. And when we do that, we already know that our numbers that are the last and the first are adjacent. So we can connect our tube of numbers end for end and have our torus. I think that's a fun new way to look at the matrices as well. There is also a low to high number sequence that I will mention with a 5 that's flipped. So here we see one side of the cube would be a 1, 2, 3, 4, the opposite side being 5, 6, 7, 8. Going clockwise, we might expect the 5 at the bottom, but it has flipped or shifted to continue that low to high number sequence. I'm mentioning that because that flip or shift is seen in a few ways in the matrices, and I will point a couple out today. I've taken the matrices and color coded it in different ways to reflect different numbers. And here we see an instance where we could wrap the matrices on itself, and that would complete the pair of 4s that are in a column that are numbers that are duplicated. If we add our 4 plus our 4, that would equal an 8. If we add our 7 plus a 7, that's 14. With a digital root of 5, our 1 plus a 1 equals 2. There we have an 8, 5, 2 showing up as our next diagonal numbers that are highlighted. Adding our 8 plus an 8 is 16 with a digital root of 7. We add our 5 plus a 5, which is 10 digital root of 1. And we add our 2 plus a 2 as a 4, giving us our 714, which is our next diagonal set of numbers. I thought that was a fun pattern to find. The nines in the rows, as well as the columns, hold themselves strongly. For instance, in the first row, we see our 9 in the last position of the cube, and in the first row of the chiral cube, it's also the last position in the first row. In the first column of the cube, our 9 is in the 8th position, and in our first column of the chiral cube, it is also in the 8th position of that first column. This matrices, it's a nice time to point out that the 5 is highlighted and half of it is in the cube and half is in the chiral, and I think that is a nod to the flipped 5 as well. I have color coded these matrices just with 3 numbers each. So the first one is with our 714s, and the second one in the violets is with the 528s. Within the diagonal rows that we've already looked at, there are pairs of numbers with those that we see in the columns. We will add our 4 plus a 1, that equals 5. We add our 7 plus a 4, which is 11, digital root of 2. And we add our 1 and our 7, giving us an 8. So we have another reflection here of the 528. Going within a row and looking at the numbers between the highlighted numbers, we can add our 2 and our 3, giving us a 5. Our 5 plus a 6 is 11, digital root of 2, and our 8 plus 9 is 17, digital root of 8. So we have our 5 to 8 in a third way reflected to us. In the columns between the highlighted numbers, we see groups of 4 numbers. And if we added any of those groups of 4 numbers, it would sum to a digital root of 7 in the first column In the second column, those grouped numbers would sum to 4, and the third column, it would sum to 1, and then that would continue where we would have a 7 for a column, a 4 for a column, and a 1 for a column, 7, 4, and 1. An instance of that is where we take our 6 plus a 5 plus a 5 plus a 9 being 25, giving us the digital root of 7. On the left side, if we add our 1 and our 4 and our 7, that gives us a 12 with a digital root of 3. So that's what you see reflected in the column of 3's. If we add our 1 plus a 4 plus a 4 plus a 1 plus a 7 plus a 7, that is going to give us 24 with a digital root of 6. So I have a row of 6's at the bottom of the screen reflecting that. Moving over to the violet color coded matrices. If we add our 5 and our 2, that is a 7. If we add our 2 and our 8, that's a 10, digital root of 1. And if we add our 8 plus a 5, that's 13 with a digital root of 4. So we have our 7, 1, 4 reflected a second time. And again, we will go and look at the numbers between the highlighted numbers in the row. So we add our 1 with a 9 is 10, digital root of 1. We add our 3 and our 4 is a 7. And we add our 6 plus 7 being 13, digital root of 4. So here we have a 174. Those numbers are back again. Just like the columns did on the other side, we can add our 4 sets of numbers, or not sets, but our 4 numbers that are in a column between the highlighted numbers. And when we do, that sums to a specific digital root in each column. An example here has been highlighted in case it wasn't that clear on the other side what I was trying to communicate. We have our 6 moved over, our 4 moved over, our 1 moved over, and our 6, and we add those. That's 17, which gives us a digital root of 8. The next column, if we add any of those 4 numbers that are grouped together between the highlighted, we receive the digital root of 5, and then the next column over, it's a 2, and then that continues throughout the rest of the columns, being at 852 and at 852. In this one, if we add our 2 plus our 5 plus our 8, that is 15, giving us a digital root of 6. So that again is our column of 6 reflecting that. And if we add our 8 plus a 2 plus a 2 plus an 8 plus a 5 plus a 5, that's going to give us a 30 digital root of 3. So our row at the bottom of 3's is reflecting that. There's always a lot of math magical fun and patterns to play with in Metatron's cube matrices. We see that flip or shift of the 5 also highlighted here. We see a 2 and an 8 and a 5 in a, that is what we find also here, the 2 and the 8 and the 5. This matrices has been color coded to highlight our sequence, which is a 339669 sequence going diagonally from left to right and also at a different slant from right to left. And also vertically, we see that 933966. In these two matrices, we are highlighting again that the numbers run left to right and diagonally and right to left. So what we will be pointing out on the left is also seen on the right. We have the pairs of numbers highlighted that we spoke of. And here we see our 1818 pairs And again, in the same colors, we are seeing the 4-5-4-5 pairs and the 2-7-2-7 pairs that sum to 9. We are also seeing the trilogy of numbers that we were just looking at, which is our 2-5-8 and our 1-7-4s, alternating now in diagonal rows together. And we previously had seen our 3-9-6-6-9, 3-3-9-6, and that is also showing every few rows here. And again, the opposite direction diagonals, we see a 9-3-3-9-6. We see our 1-8-1-8. We see our 8-4-2-1-5, which is those trilogy of numbers alternating. And then we have our 5-4-5-4s and our 2-7-2-7s. In addition to those pairs of numbers being seen diagonally, we see that they are also found surrounding a 9. In this case, I have just highlighted the 2 and the 7 version of that, and that's also shown underneath as a reflection again of numbers that pair and sum to 9. We had already looked at our duplicate numbers that are in the columns. I had not earlier pointed out that the solution when we add those together is also given to us beside those. So for instance, our 7 and a 7 is 14, but it has the digital root of 5. There is a natural numerical directional flow to our numbers in each row, and we can compare those as well with the chiral row that matches it. Typically, when we do that, we have one flowing in one direction and one in the opposite direction. Here I have given us a view where we have 4 of the duplicate matrices added together, just for a broader, expansive view of that. And I was working on putting this together as well as having just noted that we have our natural directional flows of numbers in the rows. Doing this, I received a synchronicity in the form of a quote, and I clipped part of it out here that was relevant. It says, "Our universe is intersecting wheels moving in all directions." This is from Archangel Raphael via Kelly Kolodny, and it seemed relevant to what I was seeing and playing with in the matrices. I appreciate you, my friend. Thank you for watching.